Ladies and gentlemen, good evening. Spring Boot 3 is now general available. Spring Boot 3 is now general available. So what do we get with Spring Boot 3? The main thing is actually performance and lower cost in the clouds because of this performance. And I've marked the text already. This is the main thing. Native images with Graal VM and also native compilation, ahead of time compilation. All of this means that you will get an application that can run with a very low memory consumption. And this, of course, will save us some money on our cloud bill, and it is also much easier to scale up and down the new Spring Boot applications because it takes maybe 0.2 or 0.3 seconds to start up these native compiled applications. So that is the main thing. Another thing is that now Java 17 is the baseline. And if you want some performance, performance gain without actually changing anything in your application and without using native compilation, then you can actually just changing to Graal VM would actually give you some performance optimization usually. And another thing is that we have Tomcat 10.1.1 right now in Spring Boot 3. This will give a very quick startup. It will go from 6 to 8 seconds down to 3 seconds, something like that. That's at least what I experienced when I started up my Spring Boot 3 application. The third thing is the improved observability with micrometer and micrometer tracing. This means that there's better support for Prometheus, for instance. It's much easier to create observables for your services and thereby pick up some data about how long does it take to call the database. It can also be to call just to call your service. Support for Jakarta EE10 instead of the Java EE. This mainly means that your imports will look differently because a lot of the functionality is kind of the same. There are some changes, but it will mainly mean that your imports will be taken from the Jakarta packages instead of the Java EE package. What I will show you in this video right here, I will focus on on the Java 17 and on the Graal VM part. That's what I will focus on right now. But I think one of the reasons why they have focused so much on Graal VM and ahead of time compilation is that there are actually some competitors to Spring Boot. One of them is Micronaut. And it's actually some of the people from Spring that actually left the Spring project, and then they started this Micronaut project instead. And here they have ahead of time compilation as one of the main sales points, and one of the main reasons on how to use Micronaut instead of using Spring Boot. And of course now one of that sales argument is actually taken away. The same with Quarkus right here. Here we have Graal VM with Quarkus. Both Quarkus and Micronaut are lightweight Java backends. So I'll definitely say that Spring Boot 3 is now much more competitive than it was before. It has a better competitive position than it had before. It actually focused on Graal VM and on the native compilation. The difference, it has been possible to create native compilation for some time, but what is now but it has never been supported in as high as a degree as it is right now. That is the main change. That in 95% of the times you can actually just change to go to Graal VM or use native compilation, and it will just work out of the box. Since the class path is made build time instead of runtime, then it also means that you cannot use the profiles any longer, so that you cannot annotate your classes with add profile and then expect that to work. So there's one thing that doesn't work. And you cannot use the application profiles that you usually use where you have different we have different sets of properties and configurations that actually work on different environments. That you have to choose your profile build time. So you have to choose your application properties at build time, not at runtime. So that is one downside. But the upside is that it is just so efficient. So I've prepared this project right here. This is Spring Boot 3. First of all, if you're using IntelliJ, go and then check for updates and then update it to latest and greatest. Another thing is that you can create your project by pressing File, New Project right here. Spring Initializer, choose Java. And the default is Gradle. If I prefer Maven right now. Actually, I tend actually to change this a lot. So sometimes I use Gradle, sometimes I use Maven. But for this demonstration right here, I've chosen Maven. Java 17 right here, and then you need to choose a JDK. JDK 19 is supported, but I would recommend if you want to use the build pack, then you need to use GraalVM 17 right now, because the build pack, which is the module that will actually build the whole Docker image for us. We do not need to have local Docker image, the local Docker files any longer. We can just use build pack to create a native compiled image for us, which is quite cool. This means that we don't need to maintain our own Docker file, so that's awesome. But if you choose GraalVM 19 and if you want to use some of the features from JDK 19, the problem is that then you're actually generating a manifest.mf file that actually says Java 19, and then build pack tries to find a matching native compilation image for Java 19, and that is not available yet. So then you will get an error if you try to use build pack with that. So for now, if you don't have any good reasons to choose JDK 19, choose JDK 17, especially if you want to use the build pack, of course. And as usual, make jars not wars. Press next right here, and add, to begin with, add Lombok as usual. That's okay. Add Graal VM native support. Add the Spring Web right here. Add, what else should you add? You should add the data, of course, so you can store some data somewhere right there. We want to add the H2 right here. What else do we need to add? We also want to add the actuator. If you want to play around with Spring Boot 3, you need to add the actuator also, because that is where there's a lot of new things there. They're worth looking at. The observability. The observables. That's actually it. So with a project set up like this, then you're quite happy. You should also add Prometheus if you want to play around with Prometheus. And as you can see right here, it says Spring Boot 3.0.0. It does not say anything. That is because it is generally available now, 3.0.0. That's quite cool. And then you just press create and then finish. If you do not have JDK 17 with GraalVM installed, then you can easily get it with IntelliJ. If you use Ubuntu, then of course use SDK-man to download it. But with IntelliJ, it's actually quite easy also now to get JDKs. You just press plus right here, download JDK, and then you can then choose the GraalVM version 17. You can also see that you can also choose 19 actually if you want to do that. But right now I prefer 17, because then I can also use the build pack and then I don't need to maintain my own Docker image. Cool. I've already done that, so I will not press OK. I'll just press cancel and show you that my project JDK is 17 right here. So let us see some speed, right? Let us see some stuff. So I'll just close this one right here, terminate, and terminate. I like to, instead of just typing stuff in the terminal, then I actually like to create a package.json file, and you can create one of those by writing npm init, and then you will get a file like this, and then there's a script section right here, and you can actually place all of your scripts right there, so then you don't have to type stuff, especially if you're making demos. Then it's quite cool. It's also cool if you have some colleagues that you collaborate with, then you can actually just tell them to run the exe file or do something like that, or run the native compilation script, and then the native compilation will work, right? So If you use Windows, then there are some prerequisites for there's some requirements. You need the build tool. You need the 2019 build tools, and the way that you can get that for free by just going to Visual Studio and then download the Community Edition. So if you go to, let me just find it right here. If you go to visualstudio.microsoft.com, and again, this is only if you use Windows. If you use Linux or Mac, it is much easier. So here, then you press free the community version right here, and then you will get a setup like this, and then you say, please install Visual Studio Build Tools 2019, and I'll go press modify right here. You do not have this to begin with, so you just press install. Then you need to tick off Universal Windows Platform Build Tool like that. You have to tick off desktop development with C++, and also make sure that you have Windows 10 SDK and the C++ latest and greatest version right there. And then that's it. Then you press OK, and then you are happy afterwards. You're almost happy because you have to activate the Visual Studio C++, the Visual Studio environment variables. And the way we do that is by calling this file right here, vcvars64.bat. After you have called that, then your Microsoft environment is ready, and then you can call Maven Engin, and then you add this profile right here, native, add the native profile, and then say native compile. It's a plugin. Of course, we can also choose it from the right side right here. If you have these variables enabled all the time, then you can actually find it under plugins right here. And you can say native. You can say native compile right here, and you can tick off the profile native up here. And then it should also work. I had to use this approach with the bat file where first I called the vcvars and then I called this maven command afterwards. So, but let me know. Let me know if it worked for you without doing that actually when you run on Windows. So then you call that, and then it will take some time where it will actually compile for the local system, and then when you're done with that, then in your target folder you will actually get a Spring Boot 3.exe file right there. I'll not waste your time by actually compiling it right now because it will take some time. So let us actually just call this. Let us just start up this Spring Boot 3 application right here and see, and see the memory print and see how much, how long it will take. First of all, let us just start the application as it would be started. With a configuration. Runtime configuration like this, and then let's see how long it will actually take for the application to start up. There's a lot of things happening. That's because I'm doing some things in my application. I am exposing a REST endpoint. Here it says 2.871 seconds. It took 2.871 seconds to actually start up this application right here. And I also get a process ID. If you don't know what this number is right here, that is the process ID, and you can actually ask your system for how much memory that will take. The command is slightly different depending on whether you use macOS, Ubuntu, or if you, like me, use Windows. Right here is the process ID, so I can just add the process ID right here, and then I can run this command right here. And then I should get a memory print for how much memory it actually uses. This is allocated size, so it's actually a bit larger. So if I go say, it actually says 265 megabyte. If I go to my task manager, and if I go look right there, then it should say, it is probably this one right here, 229 megabyte. Let me try to stop it, and then we will see. 200 and, yeah, so now that process with the 229 megabyte actually stopped. I think it's because the task manager, it actually sees the used memory, while when we call this command right here, then we get the allocated memory. But actually, I don't know. I can just see that it's different numbers that I get out from that one. You can also use a command named task list if you use Windows to get the memory consumption. Now let us try something. Let us try the exe file instead. Right, that has been native compiled. It should be very fast. So run exe file. It is right here. So I'll run this script right here. Target Spring Boot 3.exe. So now we start that one up, and if we go look right here, Then we can see springboot.exe right now. It takes only 60 megabyte of memory. Whoa, what a difference, right? So we can also run this memory tasks right here. Then it will say a number right here. It actually says twice as much. And then again, I think it's because of it could also be the maximum memory. So I think it's the allocated memory and the other one is the actually used memory. But here it says 223 megabyte right here. So that's a huge difference. Let us look at the startup. How long does it actually take to start up our application? We'll go up in the top right here. Then we'll say, here we have it, Tomcat, and you can see right here it's 10.11. Tomcat 10.11. That is why we get some of the performance boosts come from that version upgrade right there. Let me just see. Started in there. That's already been started. Let us just search for started on port, and look at this performance right here. 0.5 seconds. That is amazing, right? That is really, really fast. That's cool. Okay, so let us stop it again. Okay, let us see that it actually works. So let us curl localhost and actually see that we have something that actually works. So I curl localhost port 8080, and I have this endpoint, right? I have this REST service that says, "Hello, astronauts, we are going to the moon." So it works. My application works, and it spends much less memory than usual. And it starts up extremely fast. This means it is awesome for scalability when you put it in your Kubernetes cluster, and your Kubernetes cluster chooses to scale up or down. Then it is very fast to do so. Awesome, awesome, awesome. The next thing, let us try to start the application with the image, because I've actually built an image. Again, I will not. Should we try to build the image? Let us do that actually. So we have the image. The command to do that is maven -p native, and then Spring Boot build image like this. So maven -p for profile, native Spring Boot, and build image right here. You can also call it, of course, without the native profile. Then you still don't have to maintain your Docker file locally. I'll say that's actually something you would do in the old days, because it is actually it works so well with this build pack right here that and they maintain the Java version, and it's a much smaller image that you will get. Your resulting image would be much smaller than if you try to maintain and create some kind of Docker image based on the Docker file. So if you have a Docker file in your backend application, then remove the Docker file right away and tell your colleagues that you have a much better way of actually containerizing your Spring Boot application. Now I'll just press play right here just to see if we can build one image also. I have already all of the build pack dependencies have already been downloaded, so it's much faster for me to build than it will be for you for the first time. That was a test. That's okay. And let us see what happens right now. So it still takes some time, even though that I have the. Okay, I don't have that image right now. It has to download it. Maybe a new version actually came. See, pulling builder image right there. I actually I pulled that yesterday. But maybe there must have come maybe there was some changes to that builder image. That's why it is downloading. Yeah, there must have been changes, of course, or else I would not have pulled the changes. So that is okay. That's awesome. So it pulled the builder image, and then what we'll do now, then we'll continue the build, of course. And then there was an error right now, and this was actually. Look what actually happened right here. This is because I use JDK19 in my terminal. So that was exactly because of the problem that I mentioned to you. If I go right here, then I say maven version, maven -version. Look what happens right here, Java 19. That is because I have set my Java is pointing to 19 right now and not 17. That is why I got that error. I'm actually happy we got that error right there. So let me just show it to you again. It says no valid dependencies for native 19, and then the tiny build pack right there. But there is one for 17. So I could do two things. I could go and change my Java home, or I think I can run. I think I can run this command from IntelliJ instead. Then I think the JDK that will be chosen will actually be the one from the project, if I am not mistaken. So Spring Boot and then build image. Let us try that instead right here. Spring Boot and then build image with the profile native enabled. Yes, I'll double click right there. So now it was GraalVM 17. So let us see what happens now. Let us see what happens now. Yeah. So what happens now? So now we connect. Now So now we actually found a build pack image that actually matched Java 17 instead of it trying to find Java 19. Instead, look here, using Java 17 extracted from manifest.mf. Everybody's happy. Yes, that's quite awesome. And it will stand there and build for some time. I've already built an image, so I think we will use the image that has already been built. This will just, let us find Docker images like this. I already have this image down here. Of course, this will be written very soon, but you can see how small it actually is. It is 171 megabytes, and it will get the final image will actually get the same name as your artifact, and also the same version. They will get the same tag as that's the version that you have in your current project. Of course, you can always retag this to something else, like latest or something, if you want that instead. But let us try to start up this application right here. And of course, I have created a script for that. So let us say docker run image right here. I have this command right here. It says docker run -rm, so it cleans up after itself. This means that the container will be deleted after it has stopped running. -it for interactive and terminal. I'm mapping out port 8080 from inside to port 8090 on my machine, and I'm starting up this image right here. While I was talking, maybe it was actually done. Oh, it's not done yet, but that's okay. That's okay. It continues with that stuff, with the native compilation and with the building of the image. We do not want to wait for that, so we'll just press play right here. And let us see now the image will be started up. Yes, there's the image, and the startup time is 0.7 seconds. Quite awesome, quite fast. So let us see if it actually works. This means that I need to curl port 8090 instead, and this is right here. Yes, hello astronauts. It's another version of the application that it did not say we are going to the moon. So that's the only thing. Let me just stop this one right here. I'll terminate it, and let us see what's happening right here. It is still building our Docker image. But that's actually that I will say this. If I should only mention one thing about Spring Boot 3, then that would be the thing. Optimization for the cloud, and making it possible for us to get a lower cloud bill, and also the reason why this is also important is that now we can actually use Raspberry Pis. We can use those small $5 computers, right, where we can just place our Spring Boot backend on it, and then it will actually work quite fine because of these optimization of these optimizations right here. Yeah. And there are something called, if you get problems with GraalVM and the native compilation, then it's probably because you are using reflection, or if you're using profiles, or if you're using something where the compiler cannot see on compile time what is your idea with whatever you're doing. Maybe you have some proxies or something like that. And there is actually a way to solve that. That is with GraalVM with ahead of time compilation hints. So you need to define some hints. HINTS hits, and you can actually search Stack Overflow, for instance, for these hints for how to actually set up the hints. But that is usually the solution. But in 95% of the times, I would guess that the application will just work with native compilation. So that's quite cool. And what is the alternative, you might ask, to using profiles and using and using profile application properties. And the alternative, of course, is to use environment variables. A lot of the times when you deploy something on a Kubernetes cluster, you have to use environment variables anyway. So, yeah. Because then you can, and the reason for that is that because then you can, for instance, place your secrets inside a Kubernetes secret, and then you can have that mapped in as environment variables for your Spring Boot application anyway. So environment variables is the way to go if you want to avoid the application profiles. That's quite cool. That's quite awesome. What about, wasn't there anything else, Mike, that was new? Yes, there was actually, and that is the observability part. So let me just show you how easy it actually is to observe something. First of all, if I want to turn on Prometheus, then I have to add a dependency that is named micrometer registry Prometheus like this. You can also just choose it from the list of modules. You just check off Prometheus, and then you will have this dependency right here. And of course, you also need the actuator for this to work. And you also need to turn on the Prometheus endpoints. So you'll do that by saying management.endpoints.web.exposure to include Prometheus, and then you're actually happy. These 3 lines right here, then you're quite happy. Let us start our application again. Actually, okay. So now the build is actually done. Okay, so let me look at the images now. So we will say Docker images, and here we got it. It is now it's like 3 megabytes larger than before, so that's quite good. What was I want to test Prometheus? I want to show you something with Prometheus right now, and one way to show that is actually to start up the Spring application. I'll just start it on port 8080 as a runtime configuration. That's fine. Now to start it up, I've already added some observations. Like here I have a service named space service, and I've annotated with at observed right here. And I just say I have named this space destination, and then getting a username. It's actually, it's a bit wrong. I should have named something else like destination. Get the destination like this. And then we have some low cardinality key values. These are just tags for your statistics. There's also something called high cardinality key values. The low cardinality key values are tags for your metrics and for your trace. The high cardinality key values are tags for your tracing. Let us just run this, and I'll just restart my application right here. So I have a sleep right here. That's just to get some different performance measurements. And it always returns moon. And here's my, let me just show you my REST controller right here. Quite simple. We have hello astronauts we are going to, and that's it. So awesome. Let us start up Prometheus, because Prometheus will... Our application has started now. Okay, so let me just show what actually happens now, because if we go to localhost actuator Prometheus, then we look at this format right here. This is what Prometheus will read. There's a lot of memory used by, and then we can say there's non-heap, or there's also process sometimes. There's a lot of weird data right here. But Prometheus understands this format. It understands this data, and it will actually collect all of this and put it into a searchable UI. So let us just do that. I need to start up Prometheus if I haven't gotten it running already. Let me just check in my. You can put services in. You can put services in your IntelliJ, and you can actually see which Docker containers you're running. I can see I have a Prometheus container running right here. And the reason why this works is because I have a Docker Compose YAML file right here. And then before I started this video, then I actually pressed start on this image right here, on the service right here. Prometheus image is this, and we have to map this to the local host so they can actually reach our application. Then we have to give it a one configuration file. This is the Prometheus YAML file right there. and we have to map in that configuration file into the Prometheus container. That's what we do there. Let us just look at the configuration file just quickly. I'll create some separate videos on how to set up these all of this observability and all of these tools right here. It's just to show you that the tooling and the has also it is much easier now to set up the metrics and to observe stuff with Spring Boot 3. But I'll make separate videos on that. I'll just show one thing here with the Prometheus YAML file. This is a configuration for Prometheus. Prometheus has something which is called jobs. This means that it actually monitors itself. And then we have the Spring Boot 3 application right here, and you can, of course, the job name can be anything that's for your choice. That's just something that you just organize it, just to give it some kind of name. The metric part, this is important. Actuator Prometheus, this needs to point to this location right here. This means that if you have a context in front of your application, you also need to have the context. Maybe you have some kind of context right here that says my Spring Boot app or something like that in front of all of your endpoints. Then, of course, you also have to add that to the configuration. I do not have any context at all, so that's why I can say root and then actuator Prometheus. The targets, this is the location on the local host. This Docker, the Prometheus Docker container will actually connect to this endpoint at port 8080 at the local host. So that is that's quite cool. Now let us try to go to Prometheus, and I have it right here. This is Prometheus at port 9090, so I just start up port 9090. There are no security at all by default on these Prometheus, on this Prometheus image. I can go to, and here it's a bit weird when you have to search for stuff. Here I have the space, destinations, active seconds, active count. Let us try this one right here first and say execute and say which kind of numbers we get. A graph that is it is 6. That is from, okay, that's 6. Let us try to call our application and see what actually happens. I would like to ping our application with the curl port 8080. Yes, we're going to the moon. Execute. So now it is still at 6. This was not the one I wanted. Then space. Just try this one. It says 6. It still says 6 right here. Some. It did not go up. So let us just what if I search on mic or destination? Ah, here it is, space destination. Sorry, it was the wrong thing we searched for. So space destination, seconds count. Let's try that. 6, and we'll press curl again. Yeah, look what happens over here. It's all the way over here in the right side right here. So here we have, now we're up at 2 count. Then I'll try to press play again. Then we should say 3 in the right side right here. Let's see what happens. It still says 2. I'll just call it once again. Let's see if it goes up. Yes, now it goes up to 3 and then 4. So quite cool. It actually works. We can see that, we are collecting some data, but at least that's what we can see. And we are getting a nice graph from this data right here. And of course, you can measure a lot of weird stuff right here. There's also some, was it memory or what was it? JVM stuff. Yeah. That's a lot of stuff, right? So if we go to JVM buffer total, so actually all of these metrics can be queried, of course. I think this is what I wanted to show you tonight. I will make more videos. Actually, other things. There's also something called HTTP interfaces, which will make it easier to to actually create HTTP calls to other applications. So if you have your Spring Boot application has to reach other applications, then instead of using the REST template, you can use something called HTTP interfaces, but I'll create separate videos on that. Let me just, I think I'll stop here. So thank you very much for watching. And as usual, I will upload this, I'll upload the code to my GitHub account as usual. Thank you very much. Have a great evening. Hope to see you again soon. Bye-bye.